We're moving on to the graphs of logarithmic functions. In order to understand the graphs of logarithmic functions, we'll use the observations we just made about the relationship between exponential and log numbers. Naturally, just like exponential and log numbers are related to each other, so are the graphs of log and exponential functions. As a matter of fact, logarithmic and exponential functions are inverses of each other. So we're going to quickly review what inverse relations are from grade 11. Inverse functions or relations are reflections of each other about the line y equals x. The line y equals x acts as the mirror or reflection line. Now, another thing that we need to recall about inverse relations is the fact that in order to build the inverse of a relation, we need to switch the coordinates. For example, if 0.31 is on the graph of a function, when you inverse this function, that point will move to become 1, 3. So will be reflected about y equals x line. So we're going to start by drawing the graph as the inverse of 2 to the power of x. I will quickly start drawing y equals 2 to the power of x first. So the key points here are when x equals 0, y equals 1, x equals 1, y equals 2, 2, 4, 3, 8, and x negative 1, y half, and then a quarter, and so on. I will build the inverse based on the shape of the graph y equals 2 to the x. So this point here, which was the y-intercept for y equals 2 to the power of x, had the coordinates x equals 0, y equals 1. When you inverse y equals 2 to the power of x, this point will become 1, 0. So right here. The point where x equals 1, y equals 2 for the exponential will become 2, 1. The point where x equals 2, y equals 4 will become 4, 2. When x equals 3, y equals 8, that will change to become 8, 3. So when x equals 8, y equals 3. Similarly, we have the point x equals negative 1, y equals 0.5. So that will change to become x equals 0.5, y equals 1. So the point will come down here. Next, x equals negative 2, y equals a quarter, will become a quarter, negative 2. And so on. So here we go. I introduce you to the graph of a logarithmic function, or the inverse of y equals 2 to the power of x. So let's find the equations. We're going to do a little bit of algebra here. So remember the steps to finding the inverse of a relation. We're going to start with the exponential y equals 2 to the power of x. So step number 1 is interchange x with y. So instead of y equals 2 to the x, now we'll write x equals 2 to the power of y. Step number 2, we have to express this expression in here in logarithmic form. So we're going to say that the exponent y is or equals the log. We must raise the base 2 to obtain x. So we are going to say that the equation of this purple graph, so the inverse of the exponential function, is y equals log with base 2 of x. So remember that y equals 2 to the power of x has a horizontal asymptote here with equation y equals 0. For the function y equals log with base 2 of x, which is the inverse, this will convert to a vertical asymptote where x equals 0. So we're going to compare the functions. So for y equals 2 to the power of x, we said that domain is any real number x, but range is any real number y, but y has to be bigger than 0, never 0. There are no x-intercepts. There is a y-intercept at x equals 0, y equals 1. And there is a horizontal asymptote, y equals 0. For the exponential function, on the other hand, we're going to say that the domain, see that the domain is restricted, and it's x, any real number, but x has to be bigger than 0. You see that the values of x will never exceed 0 as we go down here. For the values of y, or the range, we can tell that the y values can be negative, positive, 0. So practically any real number. There is one x-intercept in here. When x equals 0, y equals 0. And there is no y-intercept. You see how the domain of the exponential has become the range of the log function. And the range of exponential, right, has become the domain of the exponential function. Now, no x-intercept, no y-intercept. Yes, y-intercept, yes, x-intercept. And for the asymptote, horizontal asymptote of y equals 0, in the exponential we'll have vertical asymptote of x equals 0. Now we're going to practice to describe the transformations that we need to apply to y equals log with base 2 of x in order to obtain these equations or graphs. So we have a negative sign here. That would be a reflection. And the reflection this time, because we're changing the values of y, right? That means that we have a reflection about the x-axis. Now, the next example, for some reason, is the exact same as the previous one. And the next example, log with base 2 of x plus 3, is a vertical translation 3 up. Y equals 3 log with base 2 of x is a vertical expansion, 3 times taller. Horizontal translation, 4 to the right. And horizontal compression, 3 times narrower.